Once again, good morning, good afternoon. It will depend on the time that we are joining the course. Today we are going to look for the regression analysis. After looking how we can make hypothesis testing, now it is a time to look for some more statistical modeling, especially for the numerical data. So that's what we are going to look for, like regression analysis. We will see a lot on regression analysis, what is the regression analysis and why we choose the regression analysis. But our aim is like taking decision based on the data, where we are going to model the data so that it's going to be simple for us to interpret the result. We based on why we are taking decision. So let's look at the regression analysis, what it is, how it works, so that we can understand it very well. Once we really need to use it, we will see how we can also use it in a perfect way. So the regression model in R programming, we have the simple linear regression model. We are using MTK dataset below as a step to understand what the regression analysis. So without looking the practical, so we want to look for the regression analysis, what it is before going to the practical side. So the regression analysis is one of the most important tools in statistics and data science. It helps us to understand the relationship between dependent variable and independent variable, but also numerical data. So it helps us to see the relationship between variables, making the prediction based on the data in many real-world problems such as economics, health, business, agriculture, and social science. So we want to know how one variables change when the other variable changing. So that's why we use a regression analysis, and the regression analysis allows us to answer such questions in a scientific and quantitative way. So in simple terms, so the regression analysis, it study how the dependent variable or the outcome variable is influenced by one or more independent variable or predictor variable. So by giving you an example here, it's we may want to study how income affects the household consumption, or how education influence wages, or how capital structure affect the farm profitability. So those are the things, or those are the some questions that we will answer while we are looking for the regression analysis. So the why regression analysis is important. Regression analysis also, as we said, help us to explain the relationship between the variables, measure the strength and direction of an effect, predict the future and unknown values, support decision making using data, and also testing hypotheses and economical theories. Because of this advantage, regression analysis is widely used in research, policy analysis, monitoring and evaluation, and also machine learning as a part of AI in R programming. So there is also the role of R in regression analysis. So R is a powerful and open source programming language designed for statistical computing and data analysis. And of course, it provides easy data handling and cleaning tools, building the functions for regression analysis, strong visualization capability, and support for advanced model like panel data, time series, generalized linear model, and others. So in R programming, the regression models can be estimated using simple and readable command, making it excellent tool for running and applying the regression analysis. So there is also the types of R programming we cover on this course. There is when we are learning regression, we commonly start with a simple linear regression, one dependent variable and one independent variable. We are having one outcome caused by one predictor or input. So we have multiple regression where we are looking for outcome, but also more than one predictor, so more than one inputs. Okay, so an extension is or advanced level to where we have logistic regression. Mainly we are trying to predict the binary outcome, the probability things. like when we are modeling the probability of having a lung cancer or not based on the difference variables. That's where we will see the logistic regression. Panel data, it's for the econometrician, where we are trying to look for the sequence effects of something by comparing, we are trying to see the sequence effects of the variables to the outcome, but also combining with a time and looking at large amount of things. So that is panel, and also time series. It is for especially in econometrician, but for some it is also applied in a health, where we are trying to look for something but based on the time trend. So that is also what we have. So basic regression model, especially the basic linear regression model, we have y equal beta 0 plus beta 1 x plus epsilon. So where y is a dependent variable, x is independent variable, b is intercept. What we call intercept, it is a value of dependent variable without looking to the contribution of independent variable as x. So x, it is also the contribution, x, it is also the independent variable. And then the b1, it is the contribution of the independent variable to dependent variable, what we call the slope coefficient. The slope coefficient, I want you to understand this, it is a contribution of independent variable to the dependent variable. And beta 0, it is the value of y or dependent variable without contributing, without looking to the contribution of independent variables. Epsilon, it is the error it is also representing the variables, which is important, but we didn't include in our model. When we are doing a model, we assume that there is another factors which is important to the outcome we have, but we didn't include in our model because we was not interested on it, or we didn't see it. That's why we have epsilon, so representing the other variables which is not included in our model. So the goal of a regression, it is to estimate the coefficient. It is to look for the slope coefficient of the predictors, so that we can understand the pain of our outcome based on the predictors that we have. So running objective or regression analysis, by the end of this topic, the student should be able to understand the concept of regression analysis, face regression model, interpret the regression outcome, checking the model assumption, and present and explain the result clearly. So the conclusion, regression analysis combined with the other programming, providing a strong foundation for data-driven analysis. It also allows the student to move from the theory to practice, or transforming raw data into meaningful insight that support the research and decision making. So these are also the regression model in other programming, the way it looks like. And we will also have a time to make the practical exercise. But what I want you to understand, when we are trying to look for the regression analysis, the way we take decision on regression analysis, of course, those are also the RIM. This is RM. This is a code that is going to help us to run the regression model, or simple linear or multiple linear regression model. We use RM, linear model, that's what it means, and we put the bracket here. It is the dependent variable or outcome variable, and we put this sign, we add the independent variable, the predictor variable, we put the comma, and then we type the data, and we equalize with the name of the data set that we are looking for. And make sure that before starting doing the regression analysis, make sure that the data, it is continuous. We are looking for the numerical data, not categorical data, when we are doing linear regression. So once you want to see the output like this, of course you will print the summary model, you type the summary, and then you put the name of the model as you created. That's why I get this result, and which is going to ring with us, like the way you make the interpretation, you see where we have estimate. This is the beta 0, what we call the intercept. It means that this is the value of MPG without looking to the contribution of white, something like that. So this is the beta 0, and then this is the contribution of white. So sorry, so, and this is the contribution of white. So white variable to MPG, which means that for every unity increase on this, for every unity increase on YT, the MPG is going to decrease by 5.3%. So unity, not percent. So for every unity increase on WT, the MPG is going to decrease by 5.34 unity. So, and then for us, it is important before looking to the estimate, when you are playing with the interpretations of this, we are looking for the p-value. This is the probability value. So if we have this star, free star, it means that since these are also the significance codes, we are trying to look for, if we get 0.001, this is also the p-value. It means that the p-value, the error we can make while we are choosing this variable to predict MPG, it is 0.00, almost 0.01%, which means once we have the p-value which is lower than to this extent, it means that this variable also, this contribution of this variable, it has meaning to our dependent variable. That's why before trying to make the interpretation of this, we have to start by looking the p-value. If we see that the p-value is less than or equal the level of significance, the level of significance that I'm talking by default, it is 5%. You have now the authority to continue to make the interpretation of estimate. As I said, we can not start on making the interpretation of estimate without looking to the significance one. So we normally started on looking for the p-value to see if there is a relationship between, to confirm if there is the significance relationship between independent variable and dependent variable. So the way to get it, it is also to look for the p-value. This is also equal to 10 to the power 29, 10.29 times 10 to the power negative 10. This is what it means, which means that it is 000 something 0.120, which is also less than 0.05. And now here we are okay. We have seen that since we see the p-value is less than, it means that there is a relationship between WT and MPG, but we need to see to what extent, where we will come to look for the estimate here. And then after looking for the estimate, so it is also important to look for the R square, where R square also shows us to what extent, just in terms of percentage, to what extent independent variable explain the dependent variable. So here we have seen that about 75% of WT explain the MPG. So that's what I can say. And here also it is the visualization that is going to show us the relationship. Of course, this is the negative relationship, as we have seen. Since we are increasing this side is going to decrease, and this is also the code of the plotting the relationship. These are also another model, but also multiple regression model. The difference between linear regression model and multiple linear regression model, because simple linear regression model, this is also the simple linear regression model, because we are focusing on one dependent variable and one independent variable, but multiple, we are looking for one independent variable as the MPG, but also more than one independent variable. And if we need to add another variable, we will add plus sign, and then we put that variable plus sign, and then the all procedures are the same, and we have to start by looking for the p-value if this variable are a significance to our dependent variable. For example, the intercept is not meaningful when we are looking for the p-value. We normally don't consider intercept. Always the intercept are also significance to the dependent, because it is the value of the dependent, of course. So we look for the WT, where this is also significant and also this is significance, but here it is not significance, because you see the p-value, it is greater than the level of significance, and now we failed to reject the null hypothesis, where the null hypothesis saying that the data are, there is no relationship. That's why the meaning of this doesn't mean anything to the our dependent variable, since they are not significant. So without taking much time, there is also multivariate regression. So those are also the things that we have seen, and this is also the additional codes or the additional things that you can consider, where you can also merge the data. I think we have seen the way we can also merge the data in a previous video, especially for the data manipulation. So again, in our conclusion, the regression analysis is a statistical method used to examine the relationship between variables, dependent variable and independent variable, one or more. So the main objective is to understand how change of explanatory variables. If I say explanatory variables, just I'm talking about predictor, I'm talking about the cause variables, affect also the outcome variables. If we say outcome variable, it is the dependent variable, and also to use this relationship for prediction and decision making. So thank you once again for taking this time to watch this video. Now it is a time also to look for the practical side, where we are going to understand how also our programming works in a practical side. As we said, the purpose of regression analysis, this is also the introduction to regression analysis, and the purpose of it, it's like to understand the relationship between dependent and dependent. So we generate the data set as a student, as we have seen. So we have to print the result, of course. It is also math, English, study hour, and the pass. So simple linear regression. So we are trying to see if it is the relationship between the marks people they get in English based on the mathematics. So we type the model, this is the object we generate, and then we put RM. So there is no need to load any packages here, because they understand that regression, it is basic code. It is a built-in functions that is going to help us to get the regression analysis. We type the model and then put RM, linear model. This is what it means. You put the dependent variable or outcome variable, you put this sign, and then you add the independent variable, you put the comma, and then you type the data, and then you equalize with the name of the data set where our variable it is also located. So what we have, it is to run, and once I run, I need to see the result. I have to click on the summary. So once I click on the summary, this is what I get. So I have to look for the p-value. Since the p-value is less than the level of significance, the level of significance that I'm talking, it is 0.05 or 5%. So since this is low, it means that we have this star here. It means that this variable math, there is a relationship between math and English. And then I have to come here on this coefficient to see to what extent. This means that for every unit, for every point, for every marks increase on math, you see, for every 1 marks increase on math, so English is going to be increased by 0.75 marks. That's what it means. And this intercept, what it means, it is the marks of English, it is a marks of English without considering. This is the average marks of English without looking to the contributions of average marks of math. That's what it means, and that's how we do the interpretation. And also we come on R square, where R square helps us to see to what extent in terms of percentage. So R square also tells us that 68% of the 68% of English score, it is explained by the mathematics. Other 32%, it is explained by other variables. That's how we do the interpretation. We say is that 60-80% of average marks of English is explained by math. Other remaining 32, approximately 32%, is explained by other variables, which is not included in our model. So here it is also to plot the regression line, like we are plotting, we type plot, and then we started by the dependent variable, and also end up with independent variable. So those are also the things. We started, if we are plotting, sorry, we started by the independent variable and we end up with dependent variable. So here when we are looking for regression, we started by dependent and we end up with independent. But if we are plotting, we started on independent, we are making an opposite when we are plotting. So those are also what it tells us. So this result, it tells us that this is also the positive relationship. This is the positive relationship. If the math score increase, the English score also is increasing. So that's what I can say. And this is also the interpretation. We look for the coefficient, look for R square, and also the p-value. That's what we consider when we are trying to look for the regression analysis. And here we have multiple linear regression, where we are trying to predict the English by also looking for the root of factor. So here we add the study hour, since for the simple linear regression was having math as independent variable only, but only difference when we are looking for the multiple linear regression, the number of independent variable is going to increase. We are trying to predict the outcome based on a lot of facts. So that's where we do the same, and then we look for this. What we are trying to consider, we normally consider the p-value. So once we are considering the p-value, you see that there is no all the p-values that we get, it means that the p-value are greater than the level of significance. Since the p-value are greater than the level of significance, it means that we fail to reject the null hypothesis. And the null hypothesis says, on the regression analysis, says that there is no relationship between study hour and English. There is no relationship between math and English. Since we get the p-value which is higher than the level of significance, means that there is no relationship, and we cannot make the interpretation of this. And even the R square, that's what does not mean anything about the dependent variable and independent variable. So again, here the logistic regression, we are predicting the probability of passing based on the math and the study. So the difference between regression analysis and the logistic regression, it is that the dependent variable that we are focusing on, it is categorical variables, and we are focusing on binary. It is in the form of yes or no. Binary operation, it means that we have 1 and 0. And if we are predicting the probability of to get pass or to fail based on the independent variables, based on the difference variables, of course we will use the logistic regression, not linear regression. So this is the generalized linear model. That's what it means. We type the name of the model, and then we put generalized linear model, and then the pass, we need to make sure that the pass, what we are focusing on, pass is going to be 1 and fail is going to be 0, because as I said, it's going to be the linear model. So then from here, once I run this, you see that it is also the probability in 0 and 1. And once I do this, you see that the p-value is also equal to 1, which means that there is no relationship between matter and study hour for being pass or fail. So because the p-value, there is no star we have here, this means that p-value is equal to 1, 100% we made an error. So that's what it means. And also we can see the predicting variables. Those are also the kind of things we can see. So in everything, I think you have understand the multiple regression model and also logistic regression model and the even simple linear regression model. And this is what we can look for while we are trying to look for the multiple regression model. And I hope that you understand these kind of things. And I have added the other additional model here and practical exercises which is going to help you to continue to master the applications of regression analysis, but also understanding how regression analysis can work in real world application. So thank you once again for taking a time to watch this video. I think it is a time to ask a question where you are not understanding, and feel free to add a comment in the chat where you can comment what is not understandable, and we will always be there for you to support you. Thank you once again for attending the advanced advanced other programming, especially for regression analysis.